All right, hi, my name's Solis Norton. I'm a 2018 Nuffield scholar, and I'd like to present today on zero carbon and the primary sector and an energy perspective on our transition to lower emissions in 2050. I think first it's really important to put the zero carbon transition into context. For farmers in New Zealand, we know that there's a lot of science, there's also a lot of lobbying and public perception, and the farmers these days feel like that they're scapegoats for our national issue. I'd like to put 3 points to you that will alleviate that. The first is a global perspective of population and emissions. That's human population. The second is a direct method to plan a transition path and measure progress towards lower emissions. And the third is how this methodology looks when it's applied to the New Zealand primary sector and how we can use this as a flagship for other parts of the New Zealand economy and perhaps elsewhere in the world. So point one, the issue we have is that the human population is in the process of an exponential explosion. Up to around 1800, there was less than 1 billion people, and up to the present, there's been around a 5 times increase in our population. Over a similar time period, we've watched the CO2 emissions, the key driver of our emissions problem, increase tenfold in the same period. This has been the focus of our challenge, and I think we need to change that to look at the source of where the emissions come from, which is the primary energy consumption. And if we look at primary energy consumption over that same period, it's increased 15-fold. Primary energy consumption, coal, crude oil, natural gas, and a tiny little bit up here around the renewables. I think on the strength of that, we can conclude that climate change is not about belching animals. It's not about dairy farms or the agricultural sector essentially in New Zealand. It's about humans and our energy consumption and how that generates emissions. I think it's also critically about our inability or our reluctance to engage with this fact. So how do we engage? I think we need to socialise the idea of the role that energy plays in our lives. I think we need to measure it, be much more familiar with it and talk about it. There's a methodology, an emerging science to deal with this, and it's called biophysical economics. Essentially, it's accounting with energy. It would be used as an adjunct to fiscal economics. The key difference with biophysical economics is it's based in physics, thermodynamics, and the natural sciences, biology and ecology. It includes primary energy, the diesel, the firewood, the coal that our industries use from day to day, but it also considers the embodied energy that goes into creating the systems and the infrastructure that we use and we take for granted. It does not include economics. A key point of difference is that finance and economics is based on confidence, consumer confidence, whereas biophysical economics is based in physics. As an example, I'd give you my KiwiSaver COVID-19 experience, where between Christmas and March of this year, my KiwiSaver balance dropped by 50%, simply because the confidence of the consumers in the global market started to evaporate in the face of COVID-19. It makes no sense that evaporating confidence in some exotic country would empty a farmer's silage pit by 50%. So let's apply this methodology. Part of my Nuffield project, I looked at the net zero in New Zealand 2050 pathway. What I'd like to say about this when we look at the transition from an energetic perspective rather than a financial perspective is that there is a significant change in the amount of energy that we will be using per person per year when we get to these scenarios that the net zero model has projected. So all 3 of these bars are around about the same height as this bar here, which is around about 12 gigajoules of energy use per person per year. So at that same height, we're using around about the same energy per person per year as we did in the 1980s. So what does that picture look like? Well, I can give you a little bit of help. Who remembers this guy? And these fabulous Land Cruisers that my young cousin rolled down the hill and smashed, because these are days before occupational health and safety existed. Tractor technology. This is not a IT system, this is a sun guard. And these fabulous outfits that the stock agents used to use in the sale yards. At the same time, this financial modelling is suggesting that we're going to double our GDP in that same period. So where would we start to bring that about in New Zealand? Well, I would say at a national scale, COVID-19 has been a perfect example. I mean, welcome to your low emissions transition. It's our opportunity now to lose. We have less discretionary travel, both local and international. We're keeping that money at home. We have less consumption and a more local focus than what we did 6 months ago. And the key bit is the conservation of our core systems has continued, whether it's a health system, thankfully, the economic system, the education system, and all the other key bits of society that we really need are all structurally sound and intact, even though we have much lower emissions. Remarkably, we achieved much of this change in a week. The Zero Carbon 2050, that's 30 years of planning that they're talking about. And we've achieved it in pretty much a week. And that's not to say that it's finished and that there's not a labour force that we're going to need to redistribute. But the change that we made in that short period is absolutely incredible. And all we hear is the rush to get back to business as usual. As part of my Nuffield project, I visited the School of Earth and Environment at Leeds University in September in 2008. They deal with biophysical economics, and I spoke with Professor Paul Brockway and his group there for a day about how it might be applied to farming systems. This was a little bit of a novelty to them as they spent most of their time looking at these methods in the UK economy. At the end of that, we got this young fella, Zeke Marshall, to take on a master's degree over the next 2 years, and just in the last few weeks, we've published this journal, this paper, a net energy analysis of global agriculture in the journal Biophysical Economics and Sustainability. Now, I'm not going to go through the nuts and bolts of what we did, but I would like to say that at a global scale, it's identified that fossil fuel use in agriculture has increased by around about a third since the 1970s, and that if I quote the last sentence, it's that given the increasing probability of near-term fossil fuel scarcity, the growing impacts of climate change and environmental degradation, and the approaching biophysical limits of global agriculture, Odum's hoax, which essentially relates to the idea that money is based on confidence and biophysical economics is based in physics, is likely soon to be revealed. So that's a little bit airy-fairy, and let's draw it a little bit closer to the farmer's gate in New Zealand. And that would have to be He Waka Eke Noa, the primary sector's climate change commitment, which we are working through at the moment to understand how farmers may reduce their emissions. In essence, this is going to be that all farmers within the next couple of years understand their emissions, probably through use of the overseer model, which is hugely complex and a massive undertaking at the national scale. I would suggest that we include in this plan a biophysical economic analysis of our farming systems, and not just on the farm, but let's look at the farm inputs, what's happening in the management, through processing, and also to the consumption. There's no point in having an incredibly efficient farm if other parts further down our chain are going to be patently unsustainable in the future. So we use an energetic lens to look at this. The data is available. All we need is the agreement to get the right parties around the table and to make it happen. With a systems-based understanding like this, you have a whole scope to optimise the system, protect its weakest links, and for the bits that are patently unsustainable, we can seriously look at a restructure. So in conclusion, I would like to put to you that the farm animals are not the driver of climate change in New Zealand or elsewhere. Humans and energy consumption is the core issue that we're dealing with, but it's something that's very difficult for everybody to accept. Biophysical economics, I think, is a key part of engaging in a solution. And I think our farm systems, and given that the farmers have such an incredibly good understanding of the inputs and the outputs of their farm systems and the balance of those to optimise and achieve the output that they want, I think this is the perfect place to start to socialise this idea a little further. And I think when it's applied to wider agriculture more generally, I think it's a key role in finding a smooth transition for us without getting hung up on any bits that are patently unsustainable. And I think at the end of that, we'll have expanded the awareness of this method and hopefully increased the acceptance. I would like to thank Nuffield New Zealand for the opportunity for one of their scholarships. It was an incredible experience, and really it's just getting started. Thank you.